Hello my good friends, it's Roger once again getting into superconductivity, and you will not believe how simple it is. This is Dr. Boaz Almag of he's from Israel, and they are doing quantum levitation and working with superconductivity. So I'm going to let him speak, and he says the most important thing he's going to say is coming up right now, and then I will explain to you very simply how superconductivity works. It's incredibly simple.
So I'm going to take this superconductor, and now I can lock it. I can force the magnetic field lines inside the material, and it will stay locked. I can rearrange the fluxon. It will stay locked like this, or like this. And it is three-dimensional locking. This is not repulsion. It's not like two magnets. No, nothing like that. Because if I turn this upside down, it just stays. Okay? Forget everything you know about classical physics. This is different. Okay? That's my point to you. Forget everything. It's difficult, right? So, now that we understand that, yeah, we understand.
Yeah, we understand. It's just not right. The whole thing's got to start over, and it's so simple, it's unbelievable. Okay, superconductivity is simply magnetic. Earth attracts all electrons. You put anything electrons go right to Earth. Static electricity, lightning, it is an attractive source. So Earth is positive. We can get that out of the way. Cold removes electrons. That's all it is. When you are forcing electrons into something, you're heating it. When you pull the electrons out, you are making it cold. At an exact temperature, the mass loses electrons so fast it becomes positive. All right, because each particle consists of positives and negatives. The negatives are the electrons in the cloud surrounding the core, which they consider the positive. I have a different situation because there is no neutrons, but the core is going to become so the net effect will become that the atom itself will become positive in its orientation towards the Earth, and that is what pushes it away from the Earth. Now, you have all the electrons being removed so fast that at this exact temperature they're going so fast away that it becomes positive. It goes bloop, pops right up in the air, exactly at that temperature. And when it goes lower than that temperature, bloop, it drops right back down because it now has so many electrons attached to it that it is pulled down to the Earth because the Earth is positive. When all those electrons are flooded away from it, it becomes positive in its entirety, net positive, and the Earth pushes it away. All right, so that is why it pulls. And anything that is gravity is nothing more than the mass of everything being pulled to Earth because of magnetism. That is what gravity is. You have more negatives in everything than positives. Those negatives are pulled to Earth along with whatever positives are attached to them. When you push so many electrons out that you now lose the positiveness, it pops up in the air. Simple as that. Now, the positive mass floats on the positive flux lines of the entangle, and then it floats on there. See, there's positive and negative, positive, negative. So there's red ones and there's green ones. So there's bumps and bumps and bumps like that, and they get entangled. This one also has positives and negatives. He pushes it down like this, and it locks in just like Velcro into these little loops of positive and negativeness. And he can also twist it down just like this, and it hooks into these pockets, which are the little grabbers. All right, because he's got a multipole magnet underneath there. Those aren't single magnets. And what happens is when it gets so cold in the superconductor, it just drops all the electrons out of it. Now, I'm going to show you something that was interesting because he's got the positive facing, the positive is facing up. And at one point anyway, because you could see the electrons were going up in the air along with the moisture that it was condensing. Always, if you open a refrigerator door or a freezer door, you see that everything falls down to cold. Obviously, they're electrons. They're leaving, trying to get to ground because they're flooding out of there, and they're going to ground. However, when he held it in one way, it pushed it up in the air, and of course it came back down. But obviously, the positive was pushing up, and the negative potential of that vapor pushed up in the air along with it. All right? Here he goes.
Metal. They aren't magnetic and they don't have any adhesives of any kind on them. The surfaces are smooth and they don't have any noticeable grooves. I can touch them together and they don't stick. However, if I slide them together like this, they stick together like super magnets. They are clearly stuck together and I can't even pull them apart.
All right, those are gauge blocks. They're so smooth that when he slides that on a 90-degree angle and then twists it tight, he's literally locking the magnets together with their surface electrons entangled. Okay, electron flooding, in my theory, says that the core of all atoms is nothing more than positives and negatives together with an excess amount of negatives. That's what he just created here. He's forcing inside of a brass ring positives and negatives, an excess amount of negatives. That creates a tractor beam magnet. Watch this. All right, what he's going to do now is he's going to approach it with an electron. Boop, there it is. He's doing the same thing as superconductivity. It's a different mode. And I do understand what's going on here, and I think I understand the superconductivity. It really is the same thing. I see no difference whatsoever. He's shaking this. This is like heat within a molecule, and then when it flies away, that will be just like light flying off of there, or electricity moving down the line. Now, I'm seeing the same thing he's doing with superconductivity using that extreme cold. I don't see a big difference here. So now you say, Roger, how can you explain this to us in terms we can understand and see it quite simple? I said, well, that is no problem. You have an atomic bomb. When you explode it, it forces everything into this heavy mass, and the electrons that are all inside of here get so close together they want to get away from each other, they leave. And it leaves a positive core. As I told you before, positive is pushed away from the Earth, and the Earth is all positive attractive forces all around the Earth. So if you have a positive source on the Earth, it's going to push it away. So here's the beginning part of your atomic bomb going on. Boom! All of the electrons leave, and chunks of actual atoms go in pieces like hand grenades out of there. They will not be stable. They are not resonance stable. So then what happens? It starts to lift off the ground. They go straight up in the air. Why is that? Because it's now become a positive mass. It's pushed from the Earth. It doesn't shoot up there like a rocket. It's going up and it's pulling everything with it because it has to recapture all of the electrons it's lost, because it's positive now. It says, where's all my electrons? It says, well, you blew it up and they left. It said, well, get them back. And it starts pulling them back into this mushroom cloud. It goes higher and higher, more mushroom, and then all of a sudden it says, well, I got all my electrons back, I'm good to go. But guess what? All of these atoms didn't reform into regular atoms. Some of these are half atoms, quarter atoms, a tenth of an atom. They're all over the ballpark. That's called radioactivity. It falls on the little people walking around and fries them. That's it. And that radioactivity is not resonance stable. Some of it will go away almost instantaneously. Some will not go away for long periods of time. However, I think there's ways to deal with this, knowing that it is nothing more than partially built atoms. And then when they combine or they fall apart and break into other atoms, they give off huge amounts of power, and they can damage you. But I think there may be some way of irradiating these with with electrons, because that's all they need is electrons. I'm going to tell you something. The whole universe is made up not of what they talk about. It's made up of 918 positive bits and 918 negative bits in every proton. There is no neutrons. And that is what accounts for electron flooding, and not a single thing doesn't work with electron flooding. Every single thing fits electron flooding. It is unity, and it is what the universe works on. Okay, my friends, this is it. All energy exchange it's nothing more than electrons moving. High speed ones, low speed ones, floating in the air, static, lightning, electricity, sonoluminescence, chemical interactions, friction. Every bit of that is nothing more than electrons interacting with other electrons and positive potentials. Electronic flow is ether. That's all it is. When you have electricity, that's ether flowing through there. There's electrons, yes, but those are free electrons moving, forcing their way through things. Some things are easy to force through, and some things are hard. Some things are conductive, some things are insulators. Ether is on and is in and on everything. Every single bit has ether. They're free extra electrons. And I can show that, and I can prove that. And I will show that, and I will prove that. They are electrons that are in the air as static. They are electrons that flow in space as light. Well, they're not really electrons. They're back-to-back electrons and positrons. They make a photon. And they flow through space until they crash into something that has a nucleus to it. Because they're photons. They don't have a nucleus. They are the little bitty particle that floats around in the air as a free floating particle until it crashes with something, and then it turns into light. It fluffs up in a luminous glow. And I cannot account for that. I don't know how that happens, but I know it happens. Now, when that stuff interacts with other things and collides, that's energy. That's energy. There is nothing more than a collision that creates energy. Not a single thing. When they say collision, it also happens in chemistry. These things smash into each other, grabs an electron, exchanges an electron, breaks a molecule, something becomes unstable, and you get nuclear decay, or all that. It's nothing more than something breaking apart or crashing into something. And it's really the same thing. It's just that one has to break to crash into something, and one just crashes into it. That's the effect. Now, ether is electricity and heat and static and lightning and every single thing that you can think of that's electricity. That is an interaction. A hammer hitting a piece of wood. That's an electrical interaction. You are taking a bunch of molecules that are positive and negative and smashing them into a bunch of other molecules that are positive and negative. Case closed. It is collisions. That is the only thing that causes is energy. Now, because we know everything's made out of the same thing, so who cares if it's a hammer or a piece of wood or a rock or what it is? They're all made out of the same thing. They're all made out of positives and negatives. When you get right down to it, and that's where I go. I go to the bottom, because once you start to tell, oh no, we see this all happen, and then they just make up things about it. How does it happen? Whatever happened in the beginning? The beginning is there's two molecules crash together. All right. Now, ether is polar. But it's always net negative for some reason. The ether that's floating around collects on you as static electricity, and it is a negative, collecting on your body because you attract it to you, and then you tuck a water pipe, and that negative jumps from you as a little spark and goes into the ground. So we know they're negative particles. They know they collect on you. We know they go to ground. So we know these ether particles are negative particles. Right? The ether weighs is the smallest particle there is electrons, and they claim they weigh 0.00054,858. I say they weigh 0.0054833 atomic mass units, and I'm pretty sure I'm right. And they all have a -1 electron volt charge, because it's an electron. That's an electron, -1 electron volt. Protons have +1 charge. All right? Now, I think they're not understanding the proton. The proton does not have a +1 charge. It has the same charge as this because protons are the exact same weight as this. Protons don't weigh 1 atomic mass unit, which is what they say. They're not one big chunk. They are the same number of chunks as the electrons. There's 1,837 bits. They're the parts of a protium, a hydrogen atom, the most basic hydrogen 1. It's the proton of that is supposed to be just a proton. It's not. It's half and half. There are 918 positrons and 919 electrons. That gives the core a net negative charge, and then you have one additional electron in the orbital. That constructs the hydrogen atom. It's not one giant proton in the middle and one little tiny electron out there. Absolutely not. They all have the same charge. One is positive, one is negative. An upspin, a downspin. Again, I can't account for the upspin and downspin, but I know that happens. And they are locked together. There's an up and down and an up and down, side by side. They're two bar magnets back to back. And that is what a photon is. And one of them is an electron, and the other one is a positron. So there's 918 of each, and then one additional electron crunches its way in there and says, okay, I'm sticking here too. And they say, all right, you're the last guy that's getting in here. And it says everybody else stays out in the orbitals. And it only allows one to stay there because it only has the attractiveness to hold one there. So you are in the S1 orbital. And guess what? That particular construction of positrons and electrons makes this anti-gravity. It's anti-gravity. It's not just light. It's anti-gravity. It's more positive than negative to the Earth. The Earth says, you're not negative enough for me to take you. Just get out of here. And it pushes up in the air. And it says, who else we got? And it says, helium comes along. I say, helium, you're not, you're close, but no good. But you go up there with the hydrogen, you know, not quite as high as him, but, you know, get out of the way. And then you get to lithium and say, hey, lithium, just float on down here, and it just trickles down like that. And because it has enough electrical negative charge to be attracted to the positive Earth. So, that's how it works. Alright, so I guess I'm going to leave it at this. This is what photons are. Photons are light, and there's the red, the blue, and the green. And I could show, we've actually seen them, and we've seen the red particles, we've seen the green particles. And we've seen them in these chunks of these four bangers, like this. Your positive, negative, positive, negative. It's a up and a down spin. The entire universe is made only of these two particles. That's the only thing there is. And when you add them together at 918 chunks, chunks of these, you know, 18 of these, 918 of these together, they go together just like this. Just like that. And that's going to be your core. Now, if you only have this many, it might be like this. And it says, hey, these things are not going to stay here. They're going to fall off here. You say, well, what do you call that? So that's radioactivity. All right, but when you hit 918, you are the first proton. Then you hit 1836 is the first proton, but it has to have 1837 because it's hydrogen, and that keeps the hydrogen electron in its orbital surrounding it. It's simple as that. Then you go up from there, to your second proton, third proton, fourth proton, and so forth. That seems to be the positives need to have 918 holding on to 918 negatives to become stable. That's just, and there might be some way that a supercomputer could say, yes, in that form. See, because when they add together, they go plus, and sometimes this way, and then another one comes and says, oh, you're going to have to move over there because I'm taking it here, and then this one moves here, and that one goes there. And that's how they add together, but it happens instantaneous. It's just like a magnet snapping to another magnet. It's just bing, bum, done. All right. So now the other thing is he's going to show some magnets, how a circular magnet starts to create these flux line cascades. Now these are two circular magnets. Now I want you to see something. See it? Click, click, click. See it? Click, click, click. See that? I can feel it. It won't go. All of a sudden, click. Come on, come on. You're sucking up. Damn thing. Oh, all right. Oh, you know what it was? I hit that little smack there. They crack, these things. When they hit hard. But when you see it? You can see it lock. I was going to take one of these and figure out how many flux lines there are, because each one of those is a flux line. Click, 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 click. Yeah. Now, and I will show you how he shows these. They had some fabulous, I'm not putting anybody down for anything. This is fabulous research. But it's just as simple as electrons flowing away from the nucleus and creating a positive mass that elevates. All right, what's he showing here is when they turn into superconducting, they create these pipes, these strands, magnetic field trapped inside. Well, those are between the blocks of magnets. Those are, as I showed you, like here. That's in between these blocks of magnets where you have your flux lines. And then this also has its flux and it's entangled together. So that is how they flow out of there as the round magnets I just showed you.
And because this is a quantum physical effect, the magnetic field behave like quantum particles, like quantum object. You can see here in this film taken by a Japanese scientist how this flux...
All right, before he goes any further, I just want you to point out, see this? These are the flux lines. That's a flux line, that's a flux line, and then they interact on these axes as well. These other particles are going to be falling down through here. That is ether. Here goes. Whoops.
Flux line, how these magnetic field lines, they flow discretely inside the material. Remember, this is magnetic field lines.
See them moving?
They behave like particles because this is quantum physics.
See, those are the field lines. All right, it's set up like a matrix of regions and zones that should not be violated. Remember I told you they own huge regions. Well, when they start packing in against each other, this guy pushes this guy and pushes this guy, pushes this guy and pushes the other guy. Says, everybody stay 30 inches around from me, or whatever the size is. When I was in the Army, it was dress it up and cover down, 30 inches all around. These guys, I don't know, 30 nanometers or something all the way around. But they will have a certain realm that they want to possess and control. And in the open air, these molecules will just be floating. There won't be any of the structure like this, but they'll be floating around. And when I come flying through there with another electron, they are going to concuss. And they're going to glow. That's just the way it works. So here he goes.
And if you look closely at the film, you see that some of these fluxons, some of these flux lines are pins. They do not move. And the reason for that is that the superconductor doesn't like the magnetic field lines moving around.
No, because it doesn't have any extra field lines. What it's got is just enough to cover itself. These other ones are being pulled out of there as fast as they can, and it's just trying to hold on to its orbitals. Normally, it appears that all particles have excess attachments to them that we just never considered before. It's the way I'm seeing it. And, well, you know for a fact that every surface is coated with electrons. That is absolutely no question, because every atom is surrounded by electrons, and every atom adds together to make molecules. They make things, and the coating that surrounds that thing is nothing more than electrons. And I can show you gauge blocks where they entangle, the same electron fields entangle. I can show you tractor beam magnets, the same electron fields entangle. I think they're missing some of the most important things here that are just toys that demonstrate exactly what they're talking about.
So what it actually does, it locks them in place. And by doing that,
it's like Velcro.
It locks itself. Look, this is the disk before we cooled it.
All right, this is important. This is before it's cooled. They're just doing its normal thing. Then all of a sudden you're going to see these lines come through here, and those are going to be running on the places where I said there was little clicks where it locks in. See, click, 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 click. Those are these lines. I could actually measure how many lines are on here by turn it and turn it and turn it and see where it will stay stable. And then you could just draw a radius, diagonals through it and find out how many lines there are. But my point being is at a certain point when it's cold, the electrons are just going to be pouring out of there like a faucet. Here it goes.
The magnetic field lines just go through and through. And when we cool it, some of it is expelled. This is the Meissner. But some of it remain, and the superconductor locks these magnetic field lines, invisible lines. And
invisible.
What actually happens is quantum locking.
Right, and here's what it is. He's close. I mean, I agree with what he's saying, but these fields are coming up this way too, as I showed in my picture. Because these are magnets too. And then there's like 4 magnets. There's got to be more than one magnet here. There's always more than one because you need to lock into these edge fields. And those entangle in those edge fields. And he can click it down here. He can actually push it down into, because these fields are like one here, one here, one here, one here. And the same thing. Now he could push them down into the fields and then they'll stay there. Because it will force this one to create its own opposing field at the correct distance. And then they lock. It's not really that hard once you get away from the neutrons. Okay, you should watch this whole thing. It's really good. This talks about how the substrate is sapphire, which is an extreme insulator, and then you have the superconducting surface, which is it's almost nothing, 0.5 micrometers. It's like, I think 5 micrometers is a hair. Something like that. What do we got here? It's so thin that tiny little layer can hold more than 70,000 times its own weight. All right? I mean, there's a lot that people don't understand about this. Now, watch what this guy does. He's really good. Let me give you a minute or two of him playing around here.
Lock it on top of this rail, and you see it just levitates. If I had a 20 meters long rail, it would just go without any friction. You see, the amount of energy I need to move this disk is minimal because there's no friction. If I take this circular rail, you see these are just two circles of magnets. And if I take the disk and put this on the rail, you'll see that it immediately starts moving. I give it a little push, and that's enough. It will keep rotating until it warms up. So there's no friction at all. Now, I can do the same thing on this rail, but upside down, because again, this is not magnetic repulsion. So if I take this disk and pin it below the rail, it will just move below the rail. Again, forget everything you know. This is not classical physics. You forgot? Okay. So
he's right. It's not classical physics. You have to get away from the current atomic Bohr model, which is it just doesn't work. Electron flood covers everything. There is nothing that it does not work for. And if somebody can come to me with something, I'd love to hear it because I've checked every single thing that I can check. And there's nothing that I cannot account for with electron flood. So, I'd love to have somebody get a hold of me. I tried to contact these people, and I don't know, maybe they'll contact me back. I've tried almost all the top physicists that have published on these things, and nobody's responded back. So, who knows? But I do know that what I'm talking about seems to fit everything that they're asking for, and let me just show you the pictures once again. I have many videos on this, but this is a pulse red laser. Pip, 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 pip. There's only one tiny little particle in the center there, and they own this huge region as they come through space or through the air. And as these particles glow, because those are ether particles. Now, let's look at what happens next. Next thing that happens is that same wave is being accelerated into our particle crusher. It's an accelerator crusher. It crushes these particles into their own regions against each other and does exactly the same thing CERN's doing, except we're working with electron bits, photons, littlest, tiniest particles. They're working with 8,000 times bigger particles, but they are crushing their particles together as we are crushing ours. However, they use a little more expensive equipment. We used a couple of little round pins to crush as a venturi. Now, what happened to here? Well, you can see what happened. Plasma. You see these are the interference patterns. Those are repulsion patterns, not waves. Those are spinning repulsion patterns. This is a reverse EMF of the electron interference reversing because of this concussion. That is boom, 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 boom. Poof, 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 poof. You see them coming back here? That is the particle beam. All of the particles within this area have become concussed and are glowing. That is the nature of light. Now, excuse me. This is right above the slit. As they come out and start to reform, they start to spin off in these patterns. They then exit the accelerator. Excuse me. They then exit the accelerator as bosons, spinning little boson particles. I will show you the trails. They create these polarized Higgs fields because this is Cherenkov. Anybody that knows this stuff will know that. This is the bosons. Anybody that looks for bosons knows that. It's a high-speed particle. This is the magnetic field that surrounds that high-speed spinning charged particle. That is what's called Higgs fields. Now, we are working in the electron neutrino range, and CERN says they cannot work in that range. They can't find those particles. There they are. This one right here, right there, that is a reverse spinning particle, and that baby did something very strange. It did this. It created this particular particle. That's the white one. Crashed into one of the Higgs fields. I believe could be antimatter. It came from the same source. Came from the same source. I don't care what anybody says. It came from the same source, a red laser. It came out of the accelerator in this white fashion, gathering its field. I believe that's a left-hand spin. The rest of them are right-hand, which is the right-hand rule. And this one is spin left and gathered itself into itself, turned white, highly energetic, crashed into one of these, and I don't know what's happening here, but something's happening. I got a little tiny light trumpet. Now, another thing that we found was that light is a spinning particle. You see that spin? If you take this to a machinist, he'll understand. He said, that's a drill bit. That's a drill bit. This is the slot. Right? The light is spinning on the right-hand rule going forward. It comes up to here, and it now hits the slot. It goes through the slot and comes down and it shows up on the wall way down in the back. And these are the patterns. Not from a wave going this way, from this going this way. And you say, why would it make it on both sides like that? Why doesn't it just make it on this side? Because when it comes over this side, it comes through here and goes out here. And if it's right here, you get this. If it's over here, you get it over here. If it's over here, it comes through and it hooks way over here. If it's way down here, it just barely comes and you get them way over here. If it comes over and it goes through the bottom, you see it goes over the top, and now you got a place for it to sink into. They come over here and over here and over here and over here. That's what you're looking at there. That's what light is. All right, now we're going to look at some bosons. As they come out of the crusher accelerator, they are highly accelerated and highly energized. This particular one was probably coming straight through the center of the accelerator, so we can see it in its very pronounced state. You can see it expanded here, spinning to the right, which means it will drift to the left, compressing up here, getting ready to create the Higgs fields. Now, that's the blue one. We have this in red too. These are the red ones. All right. Now, they're a little less energetic. The blue is highly energetic. The red is on your very low end of energy. And that's probably the highest energy you're ever going to get out of the red. We have the green. There's green coming out of the accelerator. That's the actual particle. And you see it bip, 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 bip. It's because it just crashed into the Higgs ocean, let's call it, which is the particles of the atmosphere that are just sitting there, just hanging around, saying, we're just laying around here, and all of a sudden this guy comes through here faster than the speed of light, because we have accelerated it. And it slams into that atmosphere like a hammer against a wall. And everything starts spinning around because it is spinning. And then you see all these particles spin around its particle. That's what a Higgs field is. All right, you saw the particle accelerator. This is where that stuff starts to reform, and then you get two pulses of they're back-to-back dipoles. There's no question. That's got power. That's got no power. That's got power. That's got no power. Same thing here, only it is flopped over. Now, I don't know what the significance of that is, but I can tell you one thing. That came out of a red laser, and that is a dipole, two of them back to back, which accounts for what they say is a photon. It has no charge. You know, it presents itself as a neutral charge because it's net neutrality. However, there is polarity to it, and it breaks apart as a positive, an up spin and a down spin together makes a photon. One of them is an electron, one's a positron. This is very cool. This is the blue, which is extremely powerful, crashing through glass. That's glass. And you can see that it's risen up here because this is the most intense interaction. It's slamming into these glass particles and creating this disruption in the actual fabric of the glass. And then as it continues on, the fields radiate around it and sort of dip back, and you can see it pulsing through. And there's the green electrons. And all I can take from this is some kind of a torus. And it's working with what I call it, capacitive and inductive reactants. Which capacitive inductive reactors. I think the inductor is the vortex tube that spins down into the center of the torus. It does the exact same thing as our particle crusher. It spins and spins and spins, and then it crushes itself. It's called inductance. That creates a reverse EMF, which we saw in our light. Well, I'm going to show it to you because I'm going to relate this to our particle crusher. So virtually the same thing. There's a vortex at the top and the bottom of the torus. There's appears to be some kind of a right-hand rule spin, and it spins right, and then right down. And then when it reverses, it's still spinning right, and it's reversing. It makes it into a left-hand spin because it's reversing its direction. That's the critical part, is what direction it is compared to the spin. If it's going this way, the spin will be this way. If it's going this way, the spin is that way. So it's an up spin and a down spin. And that's what we're seeing here. And I think it's being choked in the center of the torus. And then it's expanding in its capacitance in the bulbousness of the torus. I don't have anything else I can assume. I can see it's being crushed. Something's being fed out of the top and bottom. There's some crushing going on there That's what I'm taking from it. If you can see it some other way, well, I'd like to know why. But that's what I'm seeing. And it happens in the red, happens in these. Now, the one thing that upsets me, or doesn't upset me, but it sort of concerns me, that my theory works on the fact that there's one of these is for the red, and a double of these is for the green, and a triple of these is for the blue. That's the difference. That one's heavier, and I see the red and the blue and the green looking virtually the same. Now, is there a side in the back that holds on to this? If that's the case, I'm good. If the red is just these two, that's perfect. If the green is just these two, I got an issue. If the green is this, and then there's another one on the side of it, I'm good. So we need to do some work, and I need to know how much that weighs. That should weigh The green should weigh twice as much as the red. And the red weighs 0.00110 atomic mass units, so it should weigh 0.00220, I would assume. You know, there's some work to do on the little details. We need some bean counters in here. But anyway, my friend over in France, Renz, sent me this. Red, blue, green, red, blue, green, red, blue, green. That's the Higgs fields coming right off his thumb, holding it up against the sun. You see the size of these fields? That's his thumb. That's the size of his fields. That's the size of your fingernail. It's the size of these fields coming down here. So don't tell me these electrons are so tiny you can't see them. There's an electron in the center of this, and the field is created because that electron now has been semi-excited, and it's flipping. You see it? It's flipping the field coming down here. That's a half a Venturi. A full Venturi is nothing more than 2 thumbs. Now, this is what I'm working on, electron neutrinos. They say they can't find these. They spend billions of dollars trying to find these. We got them for less than, I think it's about $100 total. That's them, electron neutrinos. And what has happened? A high-speed electron, which is Cherenkov radiation, which is higher speed than it should be for the media that it's going to encounter, which is exactly what we have. We accelerated it, crushed it, sent it into the standard air that is around us, and it saw that as a concrete wall. It pops all these up like this as it showers them. See, it fractures the wall, really. They go flying, just exactly what I showed. CERN says they can only work with these. We're working with those. Now, once again, this is what CERN's looking for. I just showed you. We have the exact same thing. The collision, they got head-to-head protons, which gives you 8,000 times the mass that we're using. And then they cascade away with these bosons, and then you get the Higgs. Exactly identical. And that bolsters my claim that nothing is made of anything more than a positron and an electron. And when you build them into masses, every 1,836 particles together, of positives and negatives, 918 of each, creates a proton. There's no one big proton, 2 big protons, 3 big protons, no. There's 1836, and there's whatever, 36, whatever it is, and so forth. And that's how it works. And then the particles of these bits and pieces can jiggle around and make anything. All these things we're making, stars and all this business they're talking about, no, that's not right. These particles, you can change these around at will. I think plants actually, and your bacteria in your body and everything, is able to actually mutate these particles into different molecules, different atoms. I honestly believe that now. I don't believe any of this stuff came from the way they have portrayed all these things. Oh, it had to be made in a star. Oh, it had to be this. Oh. No. It's all built from, it's just like a building block set. It's time to look at things in a completely different way. Just like that guy said, the first words out of his mouth was to stop everything, throw it all out the window, and start over again, because that's the only way you're going to get to reality. There's so much black and tangled, spooky, fermionic, it's just absolute nonsense. Black and tangled, spooky. It isn't here, it isn't there. It's the dark matter in the universe is nothing more than the particles of light that are coming from luminous bodies. We don't see them. They're dark in space. They are matter. They have a potential energy. That's the dark matter and the dark energy they've been looking for. They just don't think it's anything. What do you think happens to it? This just boggles my mind. Everybody says you can't speak against Einstein. As soon as you say, "Oh, this isn't right," oh, they throw rocks at you. Big ones. So anyway, Mud Fossil University is the last place on the planet right now where there's any truth. Come on up and learn truth. We got it coming out of our ears. I just want to say the reason I said that with a little disdain about the only place for truth, because I can tell you my mud fossil research is absolutely 100% validated. And Yale and all the rest of them, Harvard, they have no interest whatsoever in truth. That's my opinion. and I can have my opinion. And Professor Briggs at Yale has no interest whatsoever in his profession, as far as I can tell. I've tried to get him to look at my mud fossil research for years. Not a single interest whatsoever. So I think the only place you're going to find truth right now is Mud Fossil University, because the other people are slaves to their masters. They cannot speak out about truth anymore. They are so boxed in, and I am trying to save Professor Briggs and all of his friends, because if they speak, they'll end up living under a bridge. That's the kind of educational system we live in now. You take it and you pay for it and you get what you get, and they don't care to investigate anything that proves they're wrong. That's my opinion, and that is a fact in my opinion.